So good afternoon, Dr. Raghavendra, and thanks a lot for giving your time to me, and welcome on YourPedia Education platform.
Thank you very much. Thanks for this opportunity to share whatever little work that we are doing with you today.
Yeah.
Thank you, Dr. Vijayendra.
Yeah, Dr. Raghavendra, you are presently working in a couple of research areas which are very interesting. To mention a couple of such areas, you are working in the field of sensors, biosensors, chemical sensors, and I found your research work in the field of optical fiber also, and Raman scattering, and nanomaterials, nano-devices, microfluidics. So there's a wide range of research areas in which you are working. Professor Raghavendra, recently you also, one of your projects was also displayed in first ever research and development fair, which was held in IIT Delhi. We visited that on 15th of October, and the name of the project is Plasmonic Fiber Optic Absorbance Biosensor for Low Cost and Ultra-Sensitive Tuberculosis Diagnosis. So that is a wonderful project. Professor, this entire my interaction is related to your research areas, and largely the viewers on this channel are those students who aspire to pursue their research career further, and maybe many of them are already in the research areas, academics and industries. So I'm very sure this entire information which will come from you will be of immense importance and help to all of them. So let me thank you once again, and I seek your permission to proceed ahead.
Please.
Yeah. So, Professor, my first couple of questions are related to the personality. That means in this case, I'll be asking you about you only. So, I found from your website, that you have done your graduation in electronics from Andhra University, and then you directly joined PhD after BTech in very prestigious IIT Bombay, and that is direct PhD. That means immediately after BTech. So there are stringent criteria also to get into that, and obviously there must be something in your mind that why you want to do PhD. So this opportunity is available nowadays in many institutes, and students normally are not aware whether they should go for such opportunities or not. So my first question is, what was there in your mind when you decided to directly go to PhD after BTech?
Right. In fact, that's a very important question. Thanks for asking this question. I have done my graduation and I have done my bachelor's in electronics and instrumentation engineering from Andhra University. So I had a GATE score way back in 2002 when I passed out. I took a break for 1 year and I worked as a lecturer in one engineering college, a good one, Gayatri Vidya Parishad Engineering College in Visakhapatnam. So that in fact has given me has allowed me to feel the importance of teaching as well as research. So when we want to teach any subject to the students in detail, sometimes it is important to have a good in-depth knowledge of what we are teaching. So that in-depth knowledge comes with a little bit of practice in the field, and that sometimes by doing a little bit of research, you will be able to gain that expertise. So that helps in teaching the concepts to the students in a nice way, so that they can understand easily. So that's how I felt. Probably research is something that is very important. Going in depth is very important. And with that GATE score I have, so there were basically two institutions that time, IISc Bangalore and IIT Bombay, who were accepting direct PhD applicants. So and GATE qualification is the criteria. So I have applied to IIT Bombay in biomedical engineering, and I was successful. And that was in fact a life-changing moment for me.
Dr. Raghavendra, let me ask the same question a little differently. Why? Because a lot of students keep asking this question, and I'm very sure you are the best person to answer this. Students have this doubt in their mind that, sir, PhD is a very long commitment, and as we know, it is. And after BTech, it becomes even longer because number of years of investment after BTech are 5 to 6 years. So right. How a student can be sure that this is the path he should take?
Right. In fact, I would say that if we are clear about learning a lot, most of the times I felt, at least after completing my bachelor's, I felt that what I learned is not really not sufficient as such. So I thought I should be able to go for a program in IIT so that I can get more exposure.
Okay.
So that's how I felt. Whether PhD takes 5 years or 6 years, it all depends on us.
Okay.
How hard we are going to work, how smart we are.
Okay.
There is no fixed duration for a PhD program.
Yes.
So,
Yes.
however, government now provides scholarship for 5 years.
Okay.
It's not necessary that uh, one has to be there for 5 years. One can
5 years.
complete their PhD in 3 years or 4 years as well.
Okay, wonderful. So, rightly said, Professor Raghavendra, that it is the learning, it is the passion and your urge for learning that will make you survive in such kind of long duration programs. Wonderfully said. Professor, next thing which is of interest to me is when I saw your profile, you are from electronics background, but presently you are serving in applied mechanics department of IIT Madras. So, again, this shift, can you please explain this also to us?
Sure. In fact, Department of Applied Mechanics is one of the very old departments. Now we are aware that okay, there are civil engineering, there is civil engineering, there is mechanical engineering, all that. But earlier it used to be applied mechanics, and this mother of all these branches is applied mechanics, and out of this applied mechanics, several departments have originated.
Right.
So, for example, mechanical engineering, civil engineering.
Yeah.
So, way back in 1960s, when the institute was established at IIT Madras, they also started research in biomechanics. So applied mechanics, mechanics applied to biological systems or human body. So that's known as biomechanics. And later, basically the faculty members that time basically have expanded their horizon to complete spectrum of biomedical engineering, not just limiting to biomechanics alone. So that's how a biomedical engineering division has come up in applied mechanics department, and currently the department has got more than 10 faculty members working in particularly biomedical engineering area. So I would in fact thank you for asking this question, mainly because many people really don't know that IIT Madras offers an excellent program in MTech in biomedical engineering as well as MS and PhD programs in biomedical engineering. Through your channel, I would like to take this opportunity to let everyone know that we do offer MTech programs, we do offer MS PhD programs. Please do come and apply to these programs so that we also get very good students like you.
Okay, so Professor, like when many electrical engineers, they want to join certain departments, but like when they apply in departments like applied mechanics, their first query is which areas of their field they should prepare very well so that they get opportunity to work with professors like you. For electronic students, for instrumentation, or for electrical students of that background, like for mechanical, we tell okay, you prepare strength of material, you prepare fluid mechanics. So what are the areas in which electronic engineer should prepare or electrical engineer should prepare so that he is eligible to apply for departments like applied mechanics?
Okay, so the eligibility criteria is very much listed in a website by name research.iitm.ac.in. Right. So the interested people should go and visit there. But applied mechanics department takes students from various backgrounds, including electronics, electrical engineering, mechanical engineering, civil engineering, even ocean engineering as well. So, and even nanotechnology, for example. Okay. So we really don't distinguish between the departments. Even computer science also are welcome to actually take admission into our department.
Okay. So there is no specific area in electronic engineering which he should master to.
Right. In fact, every student, basically IITs have got a filter where the students have to qualify in GATE exam. Okay. So people must have GATE score so that they are eligible to take admission. So the GATE syllabus itself is quite exhaustive. So we expect people to be having expertise in those fields.
Wonderful. Professor, my next question now is related to your field of research. And what I found from a website is biosensors, and you are also working in chemical sensors. So can you please elaborate on these terms, biosensors, chemical sensors, what these are?
Right. So a biosensor is something basically we are trying to detect some kind of chemicals or some kind of biomolecules using a biomolecule or a biomimetic molecule as a receptor. Mm-hmm. So I'll explain this with an example. Now you already have, you see that glucometers, glucose monitors are available, pregnancy test kits are available in the market. So if you look at blood glucometers, we put a sample of blood there, and then only glucose is detected. But blood has got so many other things as well. So basically, how come only glucose is detected but not other molecules is the sensor strip that you use has got a enzyme known as uh, glucose oxidase, and that is very specific to only glucose molecules, and it will not react with any other molecules in the blood. Blood is a complex matrix. So that's how the biomolecules will enable detection of a specific detection of a particular analyte of interest. If glucose is of interest, you use glucose oxidase. If there is another, for example, in pregnancy test kit, there is something called as HCG. So in urine, urine is a sample, and urine may have so many other things also. But how do you detect HCG alone? Basically, you use something called as antibodies. Just like the immune molecules that we have in our blood, we use those similar immune molecules, but derived out of animals or cell cultures. And so these are the two examples of biosensors that are already available in the market.
Okay. Professor, your another research area is very interesting, that is optical fiber. So what are optical fibers? That is what I want to ask you, sir. And why are they used in some application instead of metal wires? We replace metal wires with optical fiber. Please share some of the application of the optical fibers.
Right. In fact, everyone is aware of optical fibers, mainly for their applications in communication. So fiber optic communication is the one that we use. Basically, all our internet and all works on this fiber optic communication through the cables laid between the oceans. So everyone is aware of that. And these these fiber optic communication involves use of a optical fiber known as single mode optical fiber, and that is very thin fiber, very thin optical fiber that actually has got very thin core, 8 microns, and then surrounded by a cladding like 125 microns. And the very thin glass, these fibers are surrounded by plastics to give us a strength, and that's how these optical fibers are used in reality. But the optical fibers that we use, I mean, by the way, to answer your other question, that why not metal wires? The metal wires typically have a lot of losses. That's the reason we do not use for intercontinental communication systems. So so that's the reason these metal wires are replaced with optical fibers wherever you need long distance communication, so that data is not lost.
Yeah, Professor, in future, as the new mode of communications are coming, so
Right.
can we say that in future maybe optical fiber will become obsolete or something? Is there any chance for that?
We really don't have an alternative to optical fibers as of now. Even the 5G that you currently we are moving towards 5G. In fact, the 5G basically the communication between the mobile and the transmission tower is its frequency basically in gigahertz. And then subsequently that all the data is now converted into optical data, optical form, and then transmitted.
Okay. So, Professor, you also have one patent in your name, and that is optical fiber probe. So, what is that? Can you please share with us that information?
In fact, we have been working on optical fiber as a sensor. We use we use something called as multi-mode fiber, which is 200 micron in diameter, not 8 micron in diameter, which is typically used in communication purpose. So, communication purpose uses single mode fiber. What we use is a multi-mode fiber, which are easy to handle. They're basically not fragile, but they're a little, larger in diameter. So these optical fibers work on principle of total internal reflection, and in particular, when we say total internal reflection, it is not really total internal reflection. The light appears just at the surface of the core, the optical waveguide, and it can interact with the surrounding medium. So what happens is essentially you will be able to monitor the surrounding medium surrounding the optical fiber. If you remove the cladding and expose the core, you will be able to monitor the medium surrounding the fiber, and that's how they become very interesting sensors. So that's one thing. And then what we have done is, instead of taking a straight fiber, we are actually have bent it in the form of a U, very thin. It's hardly the bend diameter is hardly about 1 mm. So what happens is here, why we do it is mainly because we want to increase the light matter interaction, and that's how we improve the sensitivity, and we use them for highly sensitive detection of various analytes, starting from ions, heavy metal ions, small molecules, all the way to detecting pathogens like bacteria and virus.
Okay, okay.
So that's how we the patent involves use of development of these fiber optic probes in the form of a U shape.
Okay. So, Professor, anything about the commercialization of this patent?
Right. So through IIT Madras, our laboratory has filed a patent, and it is under examination. We hope that this will be given a patent. I mean, fabrication technique for making these probes is patented by IIT Madras, and the same. And also we have developed other technologies like readout devices for these probes. And we have basically licensed this technology to a US-based startup working on oral diagnostics. The name of the company is Recover Healthcare Incorporated in US. Okay. So their interest is basically to develop oral diagnostic devices using our technology. So, and also we have transferred. We have also given a license to use this IP, intellectual property, to our own startup, ChemBioSense Private Limited.
Okay. Okay, so Professor Raghavendra, my next question is related to another your technological terms. So I was going through the website and I found these two terms, LSPR, which stands for Localized Surface Plasmon Resonance, and SERS, that is Surface Enhanced Raman Scattering. Please explain these terms, sir.
Right. So this is quite interesting. Basically, before I can simply explain what it is, I just need to talk about nanomaterials. Basically, when you talk about, when you say nanomaterials, any material that has dimensions less than 100 nanometers is known as a nanomaterial. And when we go to this nano size, nano regime, we call it as less than 100 nanometers, the materials sometimes start behaving very differently in comparison to the bulk. So, for example, we find that gold, Indians are fond of gold and silver. So probably our ancestors know about these properties, and that's how they really have valued these two metals. So in fact, gold appears yellow. All ornaments appear yellow. But you actually, if you break this gold into a nano size, less than 100 nanometers, so it appears pink, and put it in solution, this gold nanoparticle solution appears as very beautiful pink color. So why this is happening? The gold appears yellow, whereas gold nanoparticles appear pink. So what happens is when you basically have this nanoparticle, which is like even 5 nanometers to even 100 nanometers, different sizes, this gold or even silver, they have got a lot of electrons, and these are free electrons. And basically, these free electrons can take up energy from the ambient light, and basically they can vibrate. They can undergo resonance. So these free electrons, now we call them as plasmons, and these plasmons can resonate. But this phenomena is very limited to the surface of the nanomaterial, nanoparticle. So that's how we call this as surface plasmon resonance.
Okay.
And when we say localized, that means the surface plasmon resonance phenomenon is limited to a nanoparticle. Whereas you can also see the surface plasmon resonance phenomenon in a thin film coated on a glass layer or anything like that. So this is the basis for use of gold nanoparticles. In fact, I would like to draw your attention to this pregnancy test kits.
Okay.
In the pregnancy test kits, you see a pink line, test and control lines. So how does this pink color come there? It's all gold nanoparticles. So you're already using nanotechnology without your notice. So the pink color is all nanomaterial, gold nanoparticles.
So that is general, Professor, because even during COVID test kit, I found that these kind of things are used. I mean, different colors and different bars.
Yes, even COVID test kit also uses the same technology.
Same kind of technology.
So these are gold nanoparticles.
Okay.
Are the labels there?
So since you mentioned about nanomaterials, Professor, you have also worked on nano devices. So may I ask you what are the nano devices? What is the meaning of that?
So nano devices are not devices in nano dimension, but devices that make use of the nanotechnology.
Okay.
So, for example, we are developing sensors basically that actually incorporate nanomaterials, these gold nanoparticles on the surface of the fiber probe. So I mentioned fiber optic probe in the form of U-shape. We decorate this optical fiber, which is very thin, 1 mm in width, with gold nanoparticles.
Okay.
So what we do is here, the sensor has more sensitivity because of the LSPR effect that you just mentioned, name that you mentioned and we discussed. So we'll be able to use these probes for detecting any analyte, a chemical or a biomolecule, anything of interest to us in a very efficient way and to a very low concentrations. So now, whatever sensor that you have made is a nano device because it uses nanotechnology.
Okay. Professor, now after understanding these basics, whatever terminologies you explained, I want to draw your attention to the project which was displayed in IIT Delhi first ever R&D fair, that is in IIT Delhi.
Sure.
Yes, so Professor, the project name is Plasmonic Fiber Optic Absorbance Biosensor for Low Cost and Ultra-Sensitive Tuberculosis Diagnosis, which was displayed in R&D fair. Please tell us about this project now.
It's a very important topic for us, mainly because even for the country, tuberculosis, when we say tuberculosis, probably we have to realize one fact that there are about 25 lakh cases, new cases every year in India, and we are number 1 in tuberculosis, and about 25% of the total cases are in India. Okay. And in fact, you must also know that the Indian government wanted to end TB by 2025. Because of Corona, probably those plans have now been delayed. But I would assume that government is wanting to end TB at least by 2030. So one of the major problems that we have with TB is diagnosing TB in time is difficult, mainly because there are 2 techniques. There is one called a cell culture technique, and the other one is called as a gene expert. It's a nucleic acid amplification technique. It works on the same principle of PCR that where we have become aware of PCR tests through Corona pandemic. So one of the major problems is that sample collection is an issue. So people have to give their sputum, or the physician, the TB expert have to diagnose where exactly is this tuberculosis in the body. It may not be in the lungs, but it may be somewhere in brain or bones, or maybe colon, somewhere in abdomen, like that. Even eye, in fact. So one has to really diagnose it and then look at biopsy samples. So these 2 techniques, both of them, sampling is an issue. So we have come up with one idea. I mean, this idea has been existing. We are not the first people. It has been shown in literature that there is a molecule called as LAM. It is present in urine if the patient has active TB. But however, these concentrations are at very low levels, femtogram per ml levels. which cannot be detected by conventional techniques. So we have come up with a technology, and we have shown a proof of concept and published this data in a reputed journal, showing that okay, this technology that we have developed in the laboratory can be utilized to screen patients using their urine sample. Urine is a very easy to handle sample. It's non-pathogenic. So anybody, for example, you go to primary healthcare center, if somebody is coughing over 1 week or 2 weeks, or having some fever but no sputum or anything, so it's sufficient to actually take a urine sample and detect it, and that's the idea. We are yet to do clinical sample analysis and validate it and launch a product. Launching the product will take definitely some years, at least 2 years in our opinion, but that's an idea that we will be able to diagnose TB using urine, screen TB using urine as a sample.
So wonderfully explained and very relevant research, Professor. I realized I came to know many things about TB and how Indian government is serious to do away with this kind of disease from our country. Professor, next term is a term which every science student has heard, that is Raman scattering. You have worked in that particular domain also. The discovery of enhancement of Raman scattering by molecule absorbed on nanostructural metal surfaces is a landmark in the history of spectroscopic and analytical techniques. We want you to please tell us something about your investigations of different sizes of gold and silver nanoparticles to achieve the highest possible Raman enhancement. How and where this investigation, which is done by you, can be used or can be exploited for the benefit of the mankind?
Right. Thank you for this question. In fact, Raman, Sir C.V. Raman, we are all proud of him and his discovery and the Nobel Prize that he has earned for the country. Raman scattering basically is a kind of characteristic scattering that we observe from many molecules, not every molecule, but many molecules. So that is, as I said, it's a characteristic of the molecule. So you will be able to detect its presence if you find such scattering spectrum. However, one of the major problems is that Raman scattering is a weak phenomenon, and that's how to improve this Raman scattering signals, one can actually make use of this gold and silver nanoparticles. As we mentioned, there is something called as surface plasmon resonance phenomenon, and this basically provides a lot of whatever energy that the nanomaterial can absorb. This nanomaterial transfers this energy to the molecule sitting on its surface, and that's how the molecule can scatter light in a much efficient way, and the signal is now more detectable instantly. So this, in fact, has tremendous potential in various fields, including biosensing. In fact, there's a UK company which has been working on Raman scattering based diagnostics in a big way. And then Raman scattering as such is already in use for explosive detection. For example, US Army basically boosts about their capability to detect explosives. So the technology is basically the Raman scattering. The phenomenon behind the technology is Raman scattering. So they flash a laser light on a substance that they want to scan, and then get whatever scattered photons, collect those photons and analyze the data. And if the spectrum matches with that of an explosive, they say that, okay, this is explosive material.
Okay,
so that's equally valid for sometimes chemical warfare agents as well. Okay. Similar technology can be used.
Okay. So, Professor, you have also done marvelous work in the field of healthcare diagnostics, and your work on microfluidics is also wonderful. I want to ask you related to microfluidics and how can this be used for healthcare diagnostics?
In fact, I must tell you that we don't really work much with microfluidics. We have used microfluidics to some extent, but with our whatever technology that we are developing, these are more deep type sensors. So just you have a probe and simply dip it into solution, and you get the result. So why we go for dip type is basically it's more simpler. Whereas microfluidics is very important component of diagnostics, mainly because it helps in automation of the analysis. So when you can afford automation, let us assume that you are not in a primary healthcare center, but you are in a central diagnostic laboratory where hundreds of samples are getting analyzed. You basically you can use an automated system to drop the sample, and then the microfluidics basically takes care of the rest of the reaction. Mm-hmm. So microfluidics involves use of microchannels, and that's how they basically allow the sample in a controlled way, and a significant amount of sample is analyzed to get a reliable information. Okay. So in fact, we do see, I just want to cite an example for microfluidics here. Blood glucometers that we have, there are two kinds of ones. One is colorimetry, and the other one is that takes very small amount of sample. You just have to, after you prick, you have to bring the probe, whatever cartridge, to the blood, and a little amount of blood is sucked inside. So there also you see you actually have microfluidics, but you don't have any pumps there. Yes. Just by capillary effect, it goes inside. Mm-hmm. So microfluidics has got its own advantages, yes. And it can be made inexpensive as well.
Professor, your another work which is quite interesting. You have worked on absorbance properties of protein and bacteria can be exploited to develop the biosensors. So can you explain us that part also?
Right. So in fact, if you ask biologists, they quantify proteins, DNA, nucleic acids, and cell culture density, cell culture density using simple UV visible spectroscopy. So, for example, proteins absorb at 280 nanometer wavelength, whereas bacteria do scatter light in the entire spectrum, whereas DNA absorb light at 260 nanometers. So, but when it comes to protein and bacteria, you see that you have a lot of proteins on the cell wall surface. Any bacterium has got cell wall or cell membrane. So the cell membrane is basically has many proteins. Even cells inside also there are some proteins. So you can exploit this property of optical absorption by proteins at 280 nanometers to detect proteins or to detect even pathogens in a label-free manner. So we have an Indo-German project where we are developing a technology for detecting proteins and pathogens using this optical absorption principle.
Okay. So, Professor, now when we see the entire research areas in which you are working, it is truly interdisciplinary. And as it is said that any relevant research has to be truly interdisciplinary. In your case, that is quite visible. We find that you have worked in the domains of mechanical, electrical, computer science, IT, biotechnology, electronics, pharmacy, chemistry. So my question to you is, being in applied mechanics department of IIT Madras, how do you manage to work in all these interdisciplinary domains?
So the work that we do involves this much, these many expertise a little expertise in each of these different subjects. So it's not that one has to really master every subject that you have mentioned. So for example, when you want to put biomolecules or nanoparticles on a fiber surface, you need chemistry. When you want to use optical fiber, you need optics. Mm-hmm. When you want to make a nanomaterial, again, you need some chemistry and nanotechnology concepts. So when you want to play with biomolecules and develop assays, you need to have a knowledge of how these biomolecules work, and then in reality, how do they exist in blood or anything. For example, if you want to handle pathogens, how they live in water, for example. So this knowledge is essential. It's not really very tough, but of course, as you rightly mentioned, this is quite interdisciplinary, and people should have an open mind to accept that, okay, I'm an electronics engineer. By the way, electronics comes into picture because the readout devices that we have are all electronics. Mm-hmm. They involve optoelectronics. So electronics, all this is important. The only thing is we need to have an open mind to basically solve a given problem than saying that, okay, I'm a mechanical engineer or I'm an electrical engineer or a biologist, so I don't know the rest of the things. But we have been very fortunate to have our PhD students and MS scholars and many other project staff that we have. They all have an open mind to explore, learn, and then explore to actually achieve what is really needed.
Wonderful. So, Professor, with this, I have exhausted all my interaction points which I had jotted down, but still I'll ask you two more questions. Sir. One is related to the field of research in which you are. So, I understand that you are working in many domains. What in future? You have anything, any vision for you, Professor, in future? In which areas would you like to work, or you have kept something, some targets for you?
Right. So we in for future we have been developing multi-sample and multi-analyte detection systems. As of now, we are not really able to. So first of all, I have to tell this point that mention this point that diagnosis is most important for a relevant treatment.
Yes.
So, for example, if we have a fever, what kind of fever is it? Is it dengue or chikungunya or malaria or typhoid? Each of these diseases, it's all fever only, but caused by different bacteria or viruses. So we need to diagnose what kind of pathogen it is that is causing this fever, so that either antibodies can be administered, or if it is virus, antibiotics can be administered, or if it is virus, not many antibiotics work, but one has to take rest and have some other precautions.
Right.
So this is a very important question that doctors are always puzzled with when they try to treat a patient.
Yes.
So we want to develop some systems, a diagnostic system where you give a sample from a subject, and this analysis can be done in one shot. So a person comes with a fever, just collect a small blood sample, not much, maybe less than 100 microliters, and then dilute it and have our system in place, and then detect which kind of, what is that, whether it's dengue or whether it is malaria or something like that.
Okay. Wonderful. So, yeah.
So this multi-analyte analysis is very helpful in diagnostics. It's not only here, but also, for example, cardiovascular diseases.
Yes.
One of the major problems is that people come with chest pain or some relevant symptoms. We do have some solutions existing in the market, but those are still not sufficient. So we want to have some point of care devices, just like the way we want to have it for tuberculosis. We want to have a point of care devices or multi-channel systems, multi-analyte systems, basically, so that we can really diagnose whether it is a heart attack that the person is experiencing. Is it some kind of heart-related health problem, or is it some gastric problem?
Professor, now my last question of this interaction is related to the R&D fair. It was the first ever R&D which was held in IIT Delhi in October. So we could see that 23 IITs, pan IITs participation in that, and a lot of energy, a lot of good projects like yours. So what is your assessment of this particular event, and can we expect it as maybe annual function or annual fair? So
right.
How do you see this?
Right. In fact, Government of India really wants to promote innovation, as you already see in the news. We have so many government is encouraging startups. So in this direction, R&D fair is a one baby step towards this direction, because in IITs we are developing technologies, but the industry has a set of problems. There can be some kind of matchmaking that has to happen at some point of time, so that our own industry, Indian industry, adopts indigenous technologies that are cost effective, as well as it's good for either side. R&D, their own R&D, and then Government of India, because it will save a lot of foreign exchange. So industry interaction and then industry exhibiting the available technologies to industry is very important, so that they really find out what they understand what is being done, what are the technologies being developed, and we also understand as an academician what is the industry requirement. So this has enabled the first ever interaction like that, and I would say that this is going to be an annual event, as I know, as far as I know, and also it also leads to have basically development of more and more startups, exploring more and more startups that are very relevant to certain industry problems.
Wonderful. So, Professor Raghavendra, let me now bring this entire session to an end by thanking you. So, all my points which I had jotted down to discuss with you, you have provided very simplified and straightforward explanations to all these terms, and I'm very sure the viewers who will be listening to this will get immensely benefited through your answers. So, let me thank you once again, and I wish you all the very best in your future endeavors.
Thank you very much. In fact, this is a good opportunity for us to basically to reach out to your subscribers in your channel and also many other people, because we are here for encouraging talented students. We want all talented students to actually come and pursue challenging problems that are there. So many problems that are there, and IIT Madras in particular, all IITs and IIT Madras in particular, offers an excellent platform for every student who is really motivated to contribute to these problems and develop technologies. So I must appreciate you basically for taking up such an initiative and reaching out to the masses like in this way.
Thank you.
Thank you.